In this series of videos I'm attempting to repair and restore a pair of 9120A printers. In the videos so far in this series I've stripped one of the printers down, I've completely rebuilt one of the drive mechanisms, and it's gone together quite nicely. I had to replace the rubber roller and I had to make a spring to replace one of the missing clutches. In a recent comment, someone said that the purpose of the two clutches was to allow the paper to be pulled through and allow the roller to rotate. And while the arrangement of the clutches will allow that, it will allow the roller to rotate when it's not driven, that is not the primary function of these two clutches. I demonstrated their function in the previous video, and they are to allow this reciprocating drive system to advance the rubber roller. That's why there are two. If it was just a case of allowing the roller to freewheel, then only one clutch would be needed and not two. That's possibly why the previous person to work on this left out the spring that was missing. Possibly they made the same mistake and assumed that this was just a one-way drive to allow the roller to freewheel. But that's not what these are for. They're there to allow the reciprocating drive to advance the paper one line at a time each time the printer prints. So the point I'm at with this now is I've got the this mechanism reassembled up to the point where I'm waiting for a new drive belt to be delivered, but you'll notice there's a key part of this missing, and that is the print head. And that's what we're going to look at in this video. Without the print head, this printer will do nothing at all. So I need to find a solution because the print head on this has failed. And I had a quick peek inside the second of the two printers and I have exactly the same problem with that. So I'll get the print head and we'll have a look at it. Now this is going to be fairly difficult to video because the print head is incredibly small, but we'll have a look at it. I'll do what I can, but the point of this video is to try and figure out a way to proceed with the repair. Okay, so this is the print head, and all it really is a flat flex cable, a mounting bracket at one end, and the print head itself, which I'll come back to in a few minutes. This normally screws to the PCB, the control PCB, and it makes contact through the gold-plated section. It's just kind of clamped to the board, and there are matching gold-plated traces on the PCB. If you do remove one of these, then I suggest that you put some Kapton tape on this section, as I have done here. Don't put it all the way around, of course, just from about halfway down. If you don't do that, these traces have a habit of kind of peeling off, and you'll destroy the head, assuming it's any good. Now unfortunately this one and the one in the other printer I have, there's no conduction between 4 out of the 7 traces, and 2 of the others are intermittent depending on how I move the cable. This just translates the current pulses from the control board through to the actual print head, which is this series of small fingers on the end of the cable. Now unfortunately on this cable what's happened is it's delaminated. You're probably not going to be able to see this very clearly, but the two sections or two sides of the cable have separated. So I don't know how well you can see that, but looking inside you'll see that the tracks themselves have also separated, and it's just basically the two sides have become unstuck, moisture's got in there and it's corroded away the copper traces. But there's actually a join in here. The copper traces don't go all the way down. In this portion you can possibly see there's kind of a step change about this point, And these fingers are not copper, they're made out of flat tungsten wire. And the reason they're tungsten is because there's arcing at the end of them when it's printing. As I said, this is a spark erosion printer, so you get fairly low level but very hot arcing where the tips of these contact the paper. And the way this works is that during a print, this is dragged along the surface of the paper. Current is passed through one or more of the conductors, and wherever there's current going down the conductor, you get a small arc at the point where it touches the paper, and it removes the surface layer from the paper and exposes the underlying layer, which is dark, and that's what causes the image to be put onto the paper. But what's happened here is we're not getting conduction from this end through to the tungsten fingers, and so I need to find a way to repair this, and obviously it's not going to be easy, largely because of the scale. So in terms of scale, the wires are 0.3 millimeters wide. At the tip they're 0.4 millimeters on center. They do widen out. You can see possibly that as they go into the cable, they widen out slightly. Same width wire, but they're then spaced at 0.6 millimeter centers. So I need to find a way really to repair this. Now my chances of finding some suitable replacement tungsten wire is pretty much zero. So what I want to do is reuse this part of the cable, the tungsten part, and so my plan here is to very carefully separate the cable. I don't want to take the entire tungsten wires out. I want to keep this section from this to the end intact. So what I'm going to do is start by putting a very small amount of adhesive where the wires enter the cable. I'm then going to cut the cable back here and slice it on one side at this point. Sorry, I keep moving this around, hopefully you can see this. And what I can then do is remove the insulation from one side, and that will expose or hopefully will expose the tungsten. I can clean that up. What I'm then going to do is have some replacement flat flex cables made that basically mimic this portion from where the join is back to this end. That's quite easy to do that. But then I have the problem of how to join that flat flex cable back onto the tungsten. So the plan is to have gold contacts exposed on the flat flex cable that I make. It will be about a 12 millimeter section at the end. The idea is to have it mate with the wider portion of the tungsten fingers that have been exposed. Bear in mind this will then only be about this length. But then the problem of course is how to join the flat flex to the tungsten, and I've been looking at various ways of doing this. I could use a connector, a PCB connector, make a small PCB to go in here, or possibly have a connector put onto the flat flex. Before I go to that trouble, because the problem here is this is in quite a confined space, so it is important that whatever solution I come up with, it is going to allow this to be assembled back into the carrier. If I don't do that, then it's just not going to work, and this does go quite a long way into here. So whatever I do, the join is going to be part way inside this carrier, and if I use a connector I'm going to have to modify this, which I really don't want to do. So another solution I've been looking at is to use this. You probably can't see it. It's double-sided tape, but this is not ordinary double-sided tape. It's referred to as Z transfer tape, and it works a bit like the zebra strips on LCD displays. It's double-sided tape, but it's kind of impregnated with millions of very small conductive filaments that run in the Z direction, so they don't run across in the X or Y, they run up kind of through the thickness of the tape. And there's loads of these all over the tape. So when you stick two pieces of metal together with this tape, then as long as you've got a big enough surface area, then the law of averages will say that you'll have quite a number of these conductive filaments connecting the two parts together. So I've made a sample of this here. Now you're not going to be able to see this very well, and I can't really show this on the microscope. I have tried, but unfortunately my microscope's got a very narrow depth of view, so if I try and do it under the microscope it's out of focus. I'm going to try and lower the camera so you can see a bit more clearly what's going on here. Okay, so what I've made here are 6 strips of nickel wire, flat nickel wire, but I've bonded them together using this tape. So although it looks like there's just 3 strips of wire here, it's actually 3 at the bottom, 3 at the top, and they're joined together, but it's only about 6 millimeters of this tape. And the idea is that because on the print head the wire is 0.3 millimeters wide, if I use a 10 millimeter long section I should get about 3 square millimeters of contact area, which should give us quite a good conduction path. So I'm going to get the multimeter in. You're not going to be able to see it because we're zoomed in so far, but the idea is I've got some very sharp probes. If I touch these together, hopefully you can hear the meter beeping. So although these are not one piece, they are joined with this special tape. If I try and measure across the top one, I'm getting conduction. If I try and measure across the middle one, conduction, and the bottom one, again it's conduction. But if I measure between 2 adjacent ones, the meter is showing a complete open circuit. There's no conduction whatsoever. And the same with the bottom 2. I am touching the middle one. If I try and touch the other 2, I'm getting nothing. So in other words, I'm getting a conductive path across the join, but I'm not getting any shorts between the 2. And these wires are the same thickness or width as the wires on the actual print head itself. So it looks like this is a viable solution. It would need some additional tape around here, maybe a layer of Kapton tape just to close it up once it's done. But this is now the same overall thickness as the print head itself, so it would fit quite nicely back into the print head. So it looks like this might be a viable solution. The only question is, how much current can this joint carry? So what we're going to do now is have a quick look and see how well these joints can carry a current, what their resistance is. And so I'm just going to quickly set up an experiment to test this and see if this is a viable way of making this repair. Okay, hopefully you're going to be able to see this. What I've got here is 2 pieces of 0.3 millimeter wide nickel wire. They've been bonded together using the Z transfer tape, and the area of this is about 3 square millimeters, so it'd be about the same as what we would get if I went ahead and repaired as I described. What I'm going to do now is pass some current through this, and we'll keep an eye on it. We'll use the thermal camera to see if it's getting hot, and also we'll be able to see the current flowing through it and the voltage across it on the bench supply. Okay, so I've got it set to 1 volt, 5 milliamps, so we'll turn it on, and we're getting about 5 milliamps, and it's showing around 1 millivolt, maybe a bit less. And we're now passing current through the join. We'll try turning the current up, so we'll go up to 10 milliamps. And the voltage is now about 2 millivolts. We'll have a quick look at the wire through the thermal camera, make sure we're not getting any heating. I don't expect to see anything yet, there's not enough energy going on. And just so you can see on the camera what we're looking at, I'll make a couple of hotspots on the bench, and then you'll be able to see that between those 2 points is where the wire is. There's no sign of any heating yet. We'll go up to 50 milliamps. Okay, 50 milliamps, 23 millivolts. And I'll put some hotspots on the bench so you can see more clearly where we're looking. So the wire is passing between those two hotspots, and as you can see there's nothing showing whatsoever yet. And also, judging by the voltage across the join, bear in mind that we're also getting resistance where the two clips join onto the wire as well. So we'll increase this to 100 milliamps. Which is about what we need for the printer. Again, I'll put some hotspots on the bench so you can see exactly what we're targeting. Still no sign of any heating. And at 100 milliamps, 0.1 amps, we're getting 32 millivolts. That's across the entire system. I could use the sense terminals on the supply, but we're not that concerned about the absolute performance of this. We just need to get an idea as to roughly how much power this can transmit. We'll go up to 200 milliamps. Okay, so 0.2 amps, and we're showing 62 millivolts. Again, I'll put some hotspots on the bench so that you can see where we're looking. And still no sign of any heating. So what I'm going to do is go all the way up to half an amp. Okay, so that's half an amp, that's 0.2 volts. Seems to be fairly steady, dropping slightly. So it will fluctuate because we don't have a particularly good contact. It's such a small wire, it doesn't really sit very well in the clips. But okay, we'll check the temperature again. And we are now getting some heating of the join, which is not that surprising. It will heat up, but bear in mind it's the same temperature as the 2 points I've just created on the bench. So we're putting half an amp through this, and also the print heads normally wouldn't be continuously putting current through the print head, so it shouldn't be too much of an issue as long as it can pass the current without dropping a huge voltage. And we're putting half an amp through this and we're only dropping 0.2 volts, so I don't think we're going to get any particularly big problems with this. You can see there's a bit of heat starting to build up, nothing significant. It's about 1 degree above ambient, which is obviously almost nothing. So what I'm going to do now is go up to 1 amp and see what happens. Okay, so at 1 amp it's showing 605, it's fluctuating quite a bit. I suspect this is just the connections that we're making to this, but you can see now it is starting to heat up, so that's not that surprising at this current. I would fully expect that to happen. So we're up now to about 22 degrees. It looks very hot because the surrounding area is obviously cool, but what I suspect is going to happen here is we're just going to cure the adhesive more quickly in the tape. It was only put on about an hour ago and it should be there for 24 hours before it's used, but the hottest temperature I can find is about 21.5 degrees. It's about 19 degrees in the room. You can hopefully see that we're putting 1 amp through this, about 390 millivolts, about 0.4 volts. You know, most of that power will of course be being dissipated within the joint. So up to about 22.5 degrees. But as I said, this is a continuous current we're passing through this, so I think that's well within what we can expect to survive on the printer itself. The normal print head has very thin conductors, so it wouldn't normally be passing this amount of current, and as you can see, this is surviving quite nicely, so I suspect this will be quite a successful join. I can, if I need to, also extend and make the area of the join up to twice what I've got here, so we could reduce the power in the joint quite significantly. Also, if I'm using gold plated contacts on the end of the flat flex, then I suspect that might well survive even more. Okay, now if you think you might be interested in one of these cables, if you have a similar problem on one of your printers and you want to attempt this, let me know. That will just dictate how many of the cables I order. They will be quite expensive in such small quantities. Getting flat flex cables made is quite expensive, especially because I'll need gold plated fingers on both ends. But let me know if you're interested in this. If you have a similar problem with your printer, I won't be able to provide a huge amount of technical support beyond what I'm showing in these videos, so if you do want to attempt this, you will need to figure out how to complete the repair yourselves. I'm just offering to make these cables available. Also, you're going to need to know if it's going to be successful, but if you'd let me know in principle if you would be interested, it will make the project a lot easier. But either way, it should be an interesting project. Need to do something. It's not going to work with the existing setup. The cables have failed, so I need to find a solution to this. And so far, this seems to be the most promising.